Hello students, so today we will start a new exercise, that is exercise 3.5. So in this exercise we are going to come across how we can convert rational numbers into decimals. How we can convert a given rational number in decimals. That is, suppose if I will say 3 by 6. 3 by 6, this one we will convert it in decimal form. Then what we will do is we will divide them, that is 6 and 3 will divide them in this way, that is 6 will be in the divisor's place and 3 will be in the dividend place. Now here 6 and 3 we cannot divide it, so we will put one decimal point here and we will write 1 0 here. Now 6 5 times it is 30. 30 minus 30 will get here 0. Now we can say that 3 by 6 is equal to 0.5. So 3 by 6 we have converted it in the decimal form. So in this way we can convert a given rational numbers in decimal form. Now while converting these decimal numbers in decimals, we will come across that this decimal point, after decimal point, the numbers, the digits, they will either repeat or they will stop after a definite divide. That means here we can see that after decimal point we got here only one digit and the divide is over. That means the remainder is 0. So we will learn here also, that is types of decimals. That means after dividing, what type of decimals we can get here. So first one we can get here is terminating decimal. Terminating decimal, it means that when we are dividing any numbers, when we will divide a rational numbers, then after decimal point the division will be over. That means the remainder will get here 0. That means like we can say 0.8 to here also the divide is over. That means this division is finished after decimal point of 8 and 2. After decimal point 8 2. So we can write here 3.26. We can write here examples 9.3 in this way. Alright. So these are the examples of terminating decimals where after divide the division stops here. Here also we can see that after decimal point only one digit we got and the remainder here it is 0. So we can say that it shows a terminating decimal. The next that we will come across is non-terminating. Non-terminating decimals. Now here under this non-terminating decimals we will come across again two more types are there. That means they are recurring decimals and non-recurring decimals. Recurring decimals and non-recurring decimals. First let us try to know about this non-terminating decimals. That means after dividing the given rational numbers, we will come across that this divide is going on continuously. Like if we can say, if we are dividing 10 by 3, then 3 times it is 9. We will put one decimal point and we will write 1 0 here. That means 10 minus 9, 1 we got. No any other digit is there to bring down, so we will put one decimal point and we will write 1 0. Now again 3 times it is 9, again 10 minus 9 1, again we will write 1 0 here, again 3 times it is 9, again 1 0, again 9 3. It will be going on, it will go on continuously. That means such type of decimal repetitions of numbers will come across, and will come across that these numbers does not repeat. Like if we divide 7, if we divide 7 and 10, let us take 7 one times it is 7, again 3 here, we put one decimal point 0, 7 4s are 28, again we got here 2, again we write 1 0 here, again 7 to the 14, again we got here 6. It will go on like this. Now such type of decimals also will come across where the numbers it is endless, and here also the numbers they are endless. We can go on dividing in such a way it will not finish. So we'll come across such two types of division, that means where the decimal points repeat, after decimal points it is endless. So such type of numbers they are known as non-terminating decimals. Now recurring decimals, that means non-terminating recurring decimals, they are known as non-terminating recurring decimals. Now recurring decimals, it means that after decimal point this number, the number will start repeating itself. Here we can see that 3 is going on repetition, that means this 3 is repeated again and again. If we go on dividing, again this 3 will be repeated. Such type of numbers, such type of decimals, they are known as recurring decimals, where the numbers repeat, like we can say 3.333, or again we can say 2.323232. This 32 is repeating again and again. So the sets of numbers starts repeating, then we can say that it is recurring decimals. Now non-recurring decimals, here also we'll come across that after decimal point we'll come across that the decimal numbers, after decimal point the numbers they are going on continuous, but it is not repeated. That means the sets of number are not repeated. We can write here sets of numbers are not repeated. Sets of numbers are not repeated. That means after decimal point we are saying, after decimal point the sets of numbers does not repeat here. But here the sets of number it starts repeating again and again. Here we can see 3 is repeated again here, and 32 it goes on repeating. In such a way it will go on repeating. Such type of numbers they are known as recurring decimals, and the numbers where we will come across that the sets are not repeated again and again, then they are known as non-recurring decimals. Now we'll come across one formula here where we can identify terminating decimals and non-terminating decimals by looking at the denominator. Now if I will say here the denominator is 6. Here the denominator is 6. Now if we simplify it in the simplest form, we'll come across 3 1s are 3 2s are. Now we got here 1 by 2. Now after converting it in the simplest form, whatever is the denominator, if we will find the factors of the denominator, and that denominator is in the form of 2 to the power m into 5 to the power n, 2 to the power m into 5 to the power n, then only we can say that that rational number is terminating decimal. That rational number will have terminating decimals. That means the decimal point will, after decimal point the digits will stop. Now it can have only 2 to the power m also, it can have only 5 to the power n also, but it should not have other factors in it. Like if I will say we got the factors, for suppose if we have divided a number and we got the factors like 2 into 2 into 3 into 2 into 5. If we got in such a way, that means 2 is multiplied here 3 times, so 2 to the power 3 into again 3 we got here 1, so 3 to the power 1 again into 5 to the power 1. Here we can see that 5 is there and 2 is also there, but this 3 is also there. So when we will get such factors of the numbers, then we can say that it is non-terminating decimal. It will have non-terminating decimals. That means the decimals will go on continue. Remember that it can have only this 2 to the, or it can have 5 to the power n, but it should not have other than these two factors. If they have both, then also we can say that it is terminating decimal, but if they have other than this one, then we can say that they are non-terminating decimals. That means they will have non-terminating decimals. So these are the things that we'll discuss in our exercise 3.5. So let's start with our exercise. So question number 1 here. convert the following into decimal numbers. We will convert them into decimal. Now, option number C I have taken here. All they are same. You will have to divide and you will have to find the decimal expansion, decimal of it. Now here, 7 4 by 8. It is in the mixed fraction. So we will convert this mixed fraction into improper fraction. How we can convert is, we will multiply this 8 with 7. 8 into 7 plus 4. By denominator what it is, we will write the same as it is. That is 8. Now 8 into 7 it is 56 plus 4. So 56 plus 4 we will get here 60 by 8. So now we will divide them and we will find the decimal. So 8 and 60. So 8 7 times it is 56. 0 minus 6 we cannot, we will take one from here. 10 minus 6 4 and 5 minus 5 0. Now we will put one decimal point here and we will write 1 0 here. 8 5 times it is 40. So 8 5s are 40. Remainder 0. Now we can write here, therefore 7 4 by 8, 7 4 by 8 is equal to what we got, 7.5. So in this way we can convert a given rational numbers or any mixed fractions into decimal form. So let me show you question number 2, which is also same. That means there also we need to convert it into decimal number. So question number 2 here, option number E, 17 12 by 11. Here also we are asked the same thing, that means convert into decimals. So we'll do the same thing, that means we'll convert this mixed fraction into improper fraction. 11 into 17 plus 12 by 11, that is in the denominator's place. Now let us multiply 11 into 17. 11 into 17. 7 ones are 7. 7 ones are again 7. 11 here. Now here 7. 7 plus 1, 8 and 1 here. Now again we'll need to add 12 here. So let us add here itself. 7 plus 2, 9. 8 plus 1, 9 and 1. So we got here 199 by 11. Now let us divide it and convert them in decimal form. So 11 and 199. So 11, 1 times if we multiply we will get 11. If we multiply 2 times it is 22. So 11 into 1 we will get here 11. 9 minus 1, 8. 1 minus 1, 0. Now this 9 will come down. So 9 here. Now 11 into 8 will get here 88. So 11 into 8 it is 88. Now 9 minus 8 will get here 1 and 8 minus 8 0. Now no any other number is there to bring down. We will put one decimal point here and then we will write 10 here. Now we can see that it is 11 and here we can see that it is 10. It is less than this one, so we cannot divide them again. So what we will do is we will put 10 again and we will write 10 here again. That means when we are bringing two digits down together, what we used to write, 0 we used to write in the quotient and then we used to bring two digits down at a time. So the same thing, that means 2 zeros we are writing at a time. That's why we have added 10 here and then we wrote 2 zeros. So 11, 9 times it is 99. Again 0 minus 9 we cannot, so 1 we will take from here. 10 minus 9 it is 1. Here it is 9. 9 minus 9 0. So now again we will got remainder as 1. So we'll write again 10. Again we can see that it is not divisible. So we'll put one more 0 here and then here also we'll write 10. Now again 11, 9 times it is 99. Again the same thing, that means 1 we got here. Again we will write 2 zeros here and 1 0 here. Again if we go on dividing in this way, then we will come across it goes on continuous. So what we can write here is, therefore 17 12 by 11 is equal to what we got, that is 18.09. Again 09, again 09. It is going on continuous. So we can write in this way. We can represent it in dotted lines so that we can know that it is going on continuous. That means this set of 0, 9, it goes on repeating. So that is how we can convert rational numbers, given rational numbers or mixed fractions into decimals. Now let me show you question number 3 here. Convert the following decimals into rational numbers. Question number 3 and question number 7, both they are same. So I am going to do here question number 3 only. That is, convert them, these decimals, into rational numbers. So how we are going to convert here? That is 0.325. Here, first we will convert these decimals into fractions. How we are going to convert it? Here, we can see one decimal point is there. Then, after this decimal point, how many digits are there? How many number of digits are there? That we will count. That is 1, 2, 3. 3 digits are there after decimal point. So, the number we are going to write as it is, that is 325 by 3 digits are there. So, we are going to write here 1000. If there is 1 digit, we will write 10, that is 10. If there is 2 digit, that is 100. If there is 3 digit, then 1000. That means 3 zeros. Now, if it is possible to cancel them, we will cancel them. That means both the numerator and the denominator, here we can see that they are divisible by 5. So we will divide them by 5. 5, 2 times it is 10. And now 2 zeros are there. So we will write here 2 zeros. Now with the same 5, we will cancel this numerator also. Then 5, 6 times it is 30. Now here it is 32. 32 minus 30 will get 2. That 2 will be carried to the next number and it will become 25. So 5 times it is 25. Now again we can see that it is divisible by 5. So 5, 4 times it is 20 and 1 0 is left. So we write that 0 as it is. Now again 5, 1 times it is 5. 6 minus 5, 1. That 1 is carried to the next number and it becomes 50. So 5, 3 times it is 15. Now here we can see that 13 it is a prime number and 13 is divisible by 13 itself, and this 40 is not divisible by 13. So we cannot cancel them by a common factor. So what we will do is, we can write our answer, that is 13 by 40. Now it is in the form of P by Q. So we can say that 13 by 40 is a rational number. So it is converted into a rational number. In the same way, let us try to do option number E, that is 8.02. 8.02. So 8.02, first we will convert this one. That is, here we can see that 802 we can write it as 802 divided by, after decimal point we can see 2 digits are there. So we will write here 100. That means 2 zeros. Now we will cancel them by a common factor by which both the numbers they are divisible. So we can see that both the numbers they are divisible by 2. So 2, 5 times it is 10. Now this 0 is left, that 0 we are going to write as it is. Now here 2, 4 times it is 8 and this 0 we cannot divide it. So this 0 we will write as it is, and 2, 1 times it is 2. That means if you are dividing 802 in this way with 2, 4 times it is 8. Now this 0 will come down. Then 0 is not divisible, so we will bring the other digit, that is 2, also down. Then when we are bringing 2 digits down, then we used to write 1 0 here. So 2 1s are 2. So we got 401. Now this 401, it is not divisible by 2. It is not divisible by 3 also. So we will come across that they are not divisible by a common factor. So we will write them as it is, that is 401 by 50. So this is our required answer. So in this way we can convert decimals into rational numbers. Now let me show you question number 4. Question number 4 here. Write the following rational numbers in decimal form up to 4 decimal places. We are asked to write this given rational numbers in the form of decimal expression, where the decimal places it has 4 digits in it. Now this 1 by 8, what we are going to do is we are going to divide them. That means what is in the denominator's place that we are going to write in the divisor's place, and what is in the numerator that we are going to write in the dividend place. Now we will divide them. That is 8 divided by 1. 8 and 1 we cannot divide them, so we will put one decimal point here and we will write 1 0 here. So 8, 1 times it is 8. 10 minus 8 will get here 2. Again we cannot divide them since 2 is smaller than 8. So what we will do is we will write 1 0 here. Since we wrote already the decimal point, so we can take 1 0. Now 8, 2 times it is 16. 20 minus 16 will get here 4. Now again it is not possible, so we will write 1 0 again here. 8, 5 times it is 40. Now the remainder that we got here is 0. Now we got the answer, that is 0.125. So 1 by 8 is equal to 0.125. But here we can see that in the question it is given from up to 4 decimal places. So what we can do is we can add 1 0 here so that it becomes 4 decimal places. After the decimal point it becomes 4 digits. Here we can write, that is 8 into 0 again 0. If we write 1 0, then we can write in this way. So after decimal point to the right side we can add 0. It does not changes the value of that number. So after decimal point to the right side we can add zeros in the last. Alright. But in the center you cannot add zeros. Only in the last places you can add zeros. Now here in the same way, option number C, that is 2 by 3. So what we will do is we will divide them, that is 3 and 2. 3 we cannot divide this 2. So what we will do is we will put one decimal point and we will write 1 0 here. Now 3 6 times it is 18. 20 minus 18 will get here 2. Again we will write 1 0 since we already wrote the decimal point, so we can take 1 zeros. So 3 6 times again 18. Again if we go on subtracting, we will go the same series, that is 6 6 6 it goes on continuous. So what we can do here, it is 2 by 3, we can write it as 0.6666 and it goes on continuous. We can write our answer in this way. So in this way we can convert a fraction, that means a rational number, into a decimal expression. Now always remember that what is in the denominator's place that we are going to write in the divisor's place, and what is in the numerator's place, that we are going to write in the dividend place. Now let me show you next, that is question number 5. Now question number 5 and 6 both they are same. So let me show you 5 here. Without performing actual division, find out if the given rational numbers have a terminating or non-terminating decimal representation. Now here some rational numbers are given. Now without dividing them, we are asked to say whether it will have a terminating decimal expression or a non-terminating decimal expression. Now I have said you about terminating and non-terminating. Terminating means after divide the decimal expression will stop. That means it will not go on continuous. And non-terminating means it will go on continuous. That means the divide will go on continuous. Now we can easily identify that one by a common formula, that is 2 to the power m into 5 to the power n. This I have said you, that is 2 to the power m and into 5 to the power n. If it has the factors of only 2 to the power m also, then also that will have a terminating decimal expression. Or if it will have only 5 to the power n expression, that means the factors of the denominators will have this form, that means 5 to the power n or 2 to the power m, then we can say that it is a terminating decimal representation. Now here what we need to do is first, that means if they are divisible by a common factor, then we will cancel them and we will make them in the simplest form. So here we can see that it is already in the simplest form, 5 by 9. It is already in the simplest form. So what we will do is, the denominator, what is the denominator? We will find the factors of that one. So 9, we will find the factors of this 9. So 3, 3 times it is 9, again 3, 1. So what we got here, the factors of 9, that is 3 into 3, that is 3 to the power 2. That means 3 into 3, we can write it as 3 to the power 2. Now, since it does not have the same form, that means it does not have 2 to the power m into 5 to the power n, then we can say that it is a non-terminating decimal representation. So we can write our sentence in this way, that is, since the denominator denominator 9 has its factors as 3 to the power 2. Since it has the factors of 3 to the power 2, we can say that 5 by 9, it will have a non-terminating decimal representation. Therefore, it has non-terminating decimal representation. So in the same way we can find option number D also, that is 1 by 8. So what we will do is, the denominator, that is 1 by 8, the denominator here it is 8. So 8, we will find the factors of this 8. So 8, first it is divisible by 2, so divided by 2, 2, 4 times it is 8, again 2, 2 times it is 4, again 2, 1s are 2. So we got here 2 into 2 into 2, that is 2 into 2 into 2, that is equal to 2 to the power 3. Now here we can say that here 5 to the power n, 5 to the power n, it does not have this factor in it, so it has only 2 to the power m factor in it, but it will have a terminating decimal representation as it has 2 to the power m factor in it. As I have said you, if any one also it is present, only one is present, then we can say that it is a terminating decimal representation. So we can write here, that is, since the denominator that is 8 has its factors as 2 to the power 3, so we can write here, therefore 1 by 8 will have a terminating decimal representation. So in this way we can identify which will have a terminating or which will have a non-terminating decimal representation. In the same way, question number 6 also, there you will find that some fractions are given and in between that fractions plus sign is there. So what you will have to do is, first you will have to add them and then you will have to find whether it is in the simplest form or not. If it is not in the simplest form, cancel it by a common factor and then convert it in the simplest form, and then you can find the factors of the denominator and then you can identify whether it is a terminating or whether it is a non-terminating. In the same way, question number 8 also, there also you will have to pick up the rational numbers which will have a terminating decimal representation. So without dividing it, you just find the factors of the denominator and then you can pick up the rational numbers which will have a terminating decimal representation there. And in the same way, question number 7 and 3, both they are same. That is, you will have to convert that decimals into rational numbers and then if it is possible to cancel, you will have to cancel them and then you can convert it in the rational number. So that is the end of our exercise 3.5. Thank you so much.